Our project is Bee Venture. It's an adventure of an ordinary bee. It's a 2D game written in Pine Game with the simulations of the circuit using the Raspberry Pi. It's an arcade-inspired game in which our character bee is trying to collect its own honey spots, avoiding the barriers, and it also need to avoid and shoot its enemy, the hives. When the lives decrease, the character bee can eat honey pots for the increasement of life, and at the final chapter, it has to kill the boss. So the game works by using the MBU 6050 sensor, the gyro sensor. It detects the motion to control the character movement. For the game control, we use GPIO buttons that enables actions like shooting and pause. For the gameplay, the interactive obstacle items we we use to navigate the challenges and points and progress through the levels. For the real-time feedback, we use Pinecane display. It visualizes movement and interaction for immersive play. So this is our hardware setup. We have to use gyro sensor for the movement of the player, and we had two buttons, and we put a buzzer for the audio effect, and we have two LEDs that show our game state. And this is our schematic diagram that each components of the device is connected to the respective GPIO of the Raspberry Pi. So this is our main page. In our main page, we have four options: chapter 1, chapter 2, help and quit. We can choose each option by using the button 1, and we can select by using button 2. So this is our chapter 1 page. In chapter 1 page, we include tags, lives, and we show the barriers we pass, and we use Pine Game for the game display. It was inspired from the classic Flappy Bird game. This is our chapter 2, before the boss spawn part. Before the boss spawn, our text is to collect 10 points, that is 10 honey spots. And we have to avoid, or we can shoot the enemy hives coming from the right side of the display. If we collide with the enemy, our life will decrease. If our life is decreased, we can eat honey pot that is also randomly spawned, and we can increase up to 3, that is current maximum. If our life is 0, game is over. So after fulfill the test to collect 10 points, we have to kill the boss, because the boss spawn. The boss will also shoot, so we have to avoid the boss bullet, and we have to kill the boss. By we can see our on our display the boss health. If there is no honey spot generation, because we don't need to collect honey spots anymore, we only need to collect honey pots for the health. So for chapter 1, we just need to avoid the barriers. That is the entrance to the enemy land for the character B. In chapter 2, the character B successfully enter into the enemy's territory. So it only have to avoid or kill the enemy troopers with the movement with our controller, collect the honey drop, the scores, and collect the honey pot, that's the hill. So this is our game board here. So this is the help page that explains how to play for the user. If we press button 1 or 2, the help page will go outside to back to the main page. For the learning outcomes, we create a game with a custom game controller. We also learn to familiar with the Raspberry Pi sensors and low-level concepts, and as well as the Pi game. We also have learned the teamwork and text sharing. The main challenge in this project is handling the real-time button inputs. So for the solutions, we use the multi-threading that ensure the button press detection doesn't block any other game operations. A separate thread was created to monitor the shooting button, and that is allow the button press detection to run concurrently with the main game loop, ensuring immediate response to the player actions. So for the debouncing is actually a common issue when using a mechanical button is pausing. So where a single press might register multiple inputs due to the button's physical characteristics. So debouncing was implemented in the software to ignore repeated button press that occur within a short period after the initial press, and it ensures the single press to be detected. So this is our GitHub page that we upload all of our so-called assets and the documentations, and we will share it to the public. For the code analysis, this is our project setup. We have our main page, app.py, and we have chapter1.py, chapter2.py, and our assets files. So we use block execution for the in app.py. That is the block execution is like just temporarily stop the process of the app.py, and it goes to run the chapter1.py. If we select chapter 1, it goes to run chapter2.py if we select chapter 2. And after running the chapter 1 or chapter 2, our temporarily stop app.py program, app.py process will again processing. So it's this method is called block execution. It is temporarily stopping a process. It is temporarily stopping a process while other process runs. And another that process 2 is finished, the process 1 will run again. So this is to initialize the GPIO pins for the buttons, LEDs, and bezels, and also we use the MBU 6050 library for set up the MBU 6050 gyro sensor. So for the collision detection, we just use the PyTorch, we just use the Pine game library collect detect function here. So in Pine game, the game objects are the rectangle, so we can detect whether it is collect or not using this collect direct function. Collect direct, that is collision detection of rectangle, or not collect detect functions. We can use this. So we use the PyTorch for the collision detection parts, and we have to check the collision detection for the character to the points, character with the enemy bullets. We also have to handle health items, food items, and we also need to check for bullet collections with the boss. So for the generation of game elements like bullets, boss, enemy troopers, help, honey bots, honey drop, etc., we use the random dot ran int. For example, here we spawn the trooper enemies before the boss. This code is that. So for here we have to check if not boss spawn, and we will make a random range from 1 to 15, and then we spawn the enemy. If we want to if we want to generate many enemy through bus within a short period of time, we just need to um, make a smaller range with just between 1 to 30, 1 to 20, etc. But if we want to generate less enemy trooper within that certain period of time, we just need to increase the range. So the concept is the same for the food items and health items too. So this is the debouncing and multi-threading part that I mentioned earlier, that we have the challenge. We applying multi-threading for the for handling the shooting here. So this is our team corporations that has he is responsible for the game logic, pattern, buzzer, LED implementations, and the chapter one. And I'm Turao, so I will also be responsible for game logic, gyro setup, and chapter two. For the project demonstrations and co-explanations and gameplay demonstrations, long video version, you can have access through this QR code from the YouTube, and we also share our source codes from the GitHub if you are interested. So thank you for your attention, and questions are welcome.